8.4 Intersections of lines in 2 space and 3 space. So given 2 lines in 3 space, there are 4 possibilities for the intersection of the lines. The lines are distinct and intersect at a point, so there is exactly one solution. The lines are coincident, so there are an infinite number of solutions. The lines are parallel and distinct, so there is no solution. Or the lines are distinct but not parallel and they do not intersect. These are school lines and there is no solution. If the algebraic solution of linear equations gives a unique pair of numbers, the lines intersect and there is exactly one solution or intersection point. If the algebraic solution to a linear system gives equation in line 0x equals 0 or 0y equals 0, then all the x and y coordinates that satisfy the original equation will also satisfy this one. This means that the lines are coincident lines, which means that they lie on top of each other and have an infinite number of solutions. If the algebraic solution to a linear system has an equation of 0x equals 4 or 0y equals 4, then the lines are parallel and there is no solutions.
The first diagram, the lines intersect at a point, so there's exactly one solution. The second diagram shows the lines are overlapping, so there is an infinite amount of solutions. The third diagram shows that the lines are parallel, so this means there is no solution. The fourth diagram shows skew lines which do not intersect and are not parallel. Therefore, they are no solutions.
Example 1, classify each system as having 0, 1, or infinitely many solutions. So for A, line 1 is 4x minus 6y equals negative 10, and line 2 is 6x minus 9y equals negative 15. So the way to do this would be you multiply the first equation by 3 and the second equation by 2. So both the equations would be 12x minus 18y equals negative 13 and 12x minus 18y equals negative 13. You subtract them and you get 0y equals 0, which means that the equation is true for all values of y, so there are infinitely many solutions, and all of the points for x and y coordinates satisfy the original equation. For 1b, the equations are xy equals 1, 5 plus s negative 6a, and the equation 2 is 2, 1 plus t times 9 negative 12. So these equations you have to write in parametric form. So the first equation is x equals 1 minus 6s and y equals 5 plus 8s. And the second equation is x equals 2 plus 9t and y equals 1 minus 12t. So you equate the x and y variables. So 1 minus 6s equals 2 plus 9t, and which means negative 1 equals 6s plus 9t, which is your third equation. And 5 plus 8s equals 1 minus 12t, which means 4 equals negative 8s minus 12t, which is your fourth equation. You use equations 3 and 4 to solve for s and t. So negative 4 equals 24s plus 36t, which is 4 times 3, the third equation, and 12 equals negative 24s minus 36t, which is 3 times the fourth equation, and that would equal 8 equals 0s. So this equation is true for no values of s, which means there are 0 solutions to the system. So example 2 is determining if 2 lines in 3 space intersect. So line 1 is 5, 11, 2 plus s times 1, 5, negative 2. Line 2 is 1, negative 9, 9 plus t times 1, 5, negative 2. So from the equations, the direction vectors are the same, so the 2 lines are parallel. In order to solve this, you would write each equation in parametric form. So line 1 would be x equals 5 plus s, y equals 11 plus 5s, z equals 2 minus 2s, and line 2 would be x equals 1 plus t, y equals negative 9 plus 5t, and z equals 9 minus 2t. And you equate the like coordinates, so 5 plus s equals 1 plus t, which means s minus 2 equals negative 4, and that's your first equation. And then 11 plus 5s equals negative 9 plus 5t, which is 5s minus 5t equals negative 20, which is your second equation. And 2 minus 2s equals 9 minus 2t, which is 2s minus 2t equals negative 7, which is your third equation. So you arrange the equation 1 to isolate s. so s equals t minus 4. And then you substitute s equals t minus 4 into equations 2 and 3 and solve for t. So 5 times t minus 4 minus 5t equals negative 20, which means 5t minus 20 minus 5t equals negative 20, which is 0t equals 0. And 2 times t minus 4 minus 2t equals negative 7, so 2t minus 8 minus 2t equals negative 7, which is 0t equals 1. The equation 0t equals 1 has no solutions, which means the two lines are parallel and distinct. Example 3 is finding the point of intersection of lines 1 and 2. So line 1 is 7, 2, negative 6 plus s times 2, 1, negative 3. And line 2 is 3, 9, 13 plus t times 1, 5, 5. So in order to solve this, you can tell that the direction vectors are not parallel. So you write the equations in parametric form, which is line 1 is x equals 7 plus 2s, y equals 2 plus s, and z equals negative 6 minus 3s. And line 2 is x equals 3 plus t, y equals 9 plus 5t, and z equals 13 plus 5t. You equate the expressions for the like coordinates, which means 7 plus 2s equals 3 plus t, which makes 2s minus t equals negative 4. And then 2 plus s equals 9 plus 5t, which is s minus 5t equals 7. And negative 6 minus 3s equals 13 plus 5t, which is 3s plus 5t equals negative 19. You solve equations 2 and 3 for s and t, which means s minus 5t equals 7, subtracted from 3s plus 5t equals negative 19, and you get 4s equals negative 12. So s would be negative 3. Now you substitute that value in equation 2, which is negative 3 minus 5t equals 7, so t equals negative 2. And you check that s equals negative 3 and t equals negative 2 satisfy equation 1. So your left side would be 2 times negative 3 minus negative 2, which is negative 6 plus 2, which equals negative 4, which means that it equals to the right side. Now you substitute s equals negative 3 into the first line, or t equals negative 2 in line 2. So x, y, z equals 7 to negative 6 plus negative 3 times 2, 1, and negative 3, and you get 1, negative 1, and 3, which means that this system has a unique solution at 1, negative 1, and 3.
Determine if these lines are skew lines. So first of all, we will write the equation in parametric form and equate the expression for each variable, like this. After we have done so, we are going to solve equation 2 and 3 for s and t. So we are going to be using elimination. So once we have subtracted the variables, we are going to isolate for s. So in this case, s is negative s equals 1, which could be also written as s equals negative 1. So once we have found s, we can easily find t by substituting s into equation 2. So once we have substituted s into equation 2, t equals to 6. Now we can check left side and right side by using both of the variables to check if the lines are skewed. So we can check using equation 1. So the left side equals negative 13, while the right side equals negative 3, which means left side and right side are not equal. They are not parallel and they do not intersect. Therefore, they are skew lines. Example 5, the distance between two skew lines. Determine the distance between the skew lines. So the solution for this question would be the distance required is the shortest distance. It can be shown that the shortest distance between skew lines is the length of the common perpendicular. To find the solution, we will be using this formula, which means we need to know what the vector of P1 and P2 is. For that, we can use position vectors to determine vector P1, P2. We can subtract both of them together to find P1 and P2, which is equal to -3, 4, and 3. To find n, we can use the direction vectors for both lines to calculate the normal vector to the lines. We can use this formula, n equals m1 cross m2, which means we have to use the cross product of these two coordinates. So once we have determined the cross product of m1 cross m2, the answer is 5, 5, -5, which can be easily reduced to 1, 1, -1. Now we can easily use this formula to find the distance between the shortest distance between the lines. So the answer is the absolute value of -2 over square root of 3, which is equal to 1.15. Therefore, the perpendicular distance between these lines is approximately 1.15 units. The last example is determine if the lines are parallel or coincident. So this is the first line and that is the second line coordinates. So we need to equate for x and y variables. So as we've been doing, we put it in parametric form to find our three equations. And then we will eliminate one of the variables. In this case, I am going to eliminate t. So when we add both of the variables to eliminate t, we get 0s equals 0, which is not possible. Therefore, it's coincident, which means there is an infinite amount of solutions.
Are some practice questions for you guys to try out.